Okay, we're going to be starting a new unit. We're going to be looking at trigonometry, but there's a lot more to trigonometry than maybe what you learned in grade 10 about just triangles, right? We're going to be talking about trigonometry of real numbers, not just angles and not just triangles, although triangles are still an important part of what we're doing, but we're going to go beyond that and start seeing how trigonometry is used to come up with all kinds of different things. So without further ado, let's get going. Okay, so our first topic in the first couple days or first couple lessons, we're going to be talking about the unit circle. So we really got to get a grasp on the unit circle. It is essential. It is at the core of everything we know about trigonometry. It is the birth of trigonometry and where these, think about sine, cosine, tangent, those types of functions. It's basically the birthplace of where they come from. Now, some of you might have talked a lot about this in grade 10, some of you haven't talked about it at all, so I'm going to try and bring it back to basics and really get a good grasp of this. Now, if all you care about is solving triangles, that's one thing, right? We can do, different stuff, SOHCAHTOA, whatever, to solve for that. But those of you that want to go further in math have to get a really good idea of the unit circle and the core of trigonometry here, okay? All right, so let's just talk about the unit circle today. Now, what is the unit circle? Well, the unit circle is a really, really important piece of information in math, and it's a circle that has a radius of 1 unit. That's why they call it the unit circle. So it has a radius of 1 unit. So when we say 1 unit, we don't, we're not attaching a specific unit on like centimeters or feet, just one of whatever, okay? 1 unit. So it's a circle with a radius of 1, and on that circle there are x and y coordinates, right? That make it up, okay? That make up that circle. So it's got an infinite set of points, right? Because as you go along, any 2 points, you could find a point in between them. So I could say, well, here and here are a point, right? Well, there's a point in between those, and 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 we could do that forever. So a circle, mathematically, is really a set of points, an infinite set of points, right? All right. So the other thing about the unit circle is its center is at 0, 0, at the origin right there, right? So center at 0, 0, and a radius of 1. All right, so talking about that, let's just identify a few key points on this. Let me just neaten this up. I don't like how this looks. All right, so let's identify some key points, right? Because if we have a radius of 1, then from here to here is also 1, right? You're 1 over. So your coordinates would be 1, 0. So the x coordinate 1, y coordinate 0. So these are going to be some key points to keep in mind as we develop and go further over the first few days of this. All right, this point here would be 0 over 1 up, right? Over here would be -1, 0, and down here would be 0, -1. All right, so we've identified, 4 key points. There's a lot more that we're going to talk about, really certain points. Now, the thing is, there could be points here, wherever, right? And they're generally decimal numbers or numbers we can write as fractions, and we're going to look at some of those in a minute. All right, let's talk about the equation of the unit circle. The equation in grade 10 we learned of any circle with centered at the origin is x squared plus y squared equals the radius squared, right? All right, now why is that? Why is that formula? Well, let's think here. Let me just kind of draw my circle here. Let me neaten this up. I'm going to pause and neaten it up. All right, so there's x and y. So if we are to determine those coordinates, that x and y coordinate, right, what are they? They're really found by the x coordinate is found by how far I travel horizontally, right, from the origin. And the y coordinate is how far I travel vertically, right? So it creates a right-angled triangle that we're finding there. Well, a right-angled triangle, right, and this again is our radius of 1, think about it, right? We could think of as c squared equals a squared plus b squared, or a squared plus b squared equals c squared, right? Right-angled triangle, Pythagorean theorem, right? So let me just label that, right? A, b, and c. Well, it's the same thing. We've just replaced it with different letters. We've said x, y, and radius, right? It's the same formula. So x squared plus y squared equals the radius squared. Well, we've already said the radius here is 1, right? So when you take that and you replace the r with 1, right, you're going to get x squared plus y squared equals 1 squared, right? And 1 squared is just 1. So let me just write that over here, right? And that's how we get this. So this is the equation of the unit circle, right? How we can determine x and y coordinates, right? And again, it's just Pythagorean theorem, right? And again, that's by taking the radius, which is equal to 1, and squaring it, right? Oops, my equal signs are sticking together, right? Radius equals 1, and then we square it, okay? Which is still just 1. So that's how we come up with the equation of the unit circle, okay? Just want to label some important stuff here. So again, this is just from Pythagorean theorem. That's all that this is here, right? This is just Pythagorean theorem, and we've just used different variables, right? That's all that this is. So the birthplace of trigonometry is really from Pythagorean theorem, which is probably, I don't know if it's the most, but one of the most important theorems in mathematics, because we can, birthed out of this is a whole world of trigonometry. Okay, and there we go. Okay, so that's the main thing we need to know for this first lesson. Okay, we don't really need too much more. We just need to understand that this is this equation, and we got to really get used to it, know it. And this diagram I've drawn here, getting really used to this idea of, let me just kind of highlight this, that the x coordinate here is found from the length of going across, right, this way. And the y coordinate here is found from the height, right, which is, again, Pythagorean theorem. But we really need to keep that in mind as we go through the lessons for the next couple of days. We want to keep bringing it back to that core idea, connecting what we're learning back to the unit circle and this x and y coordinate, because as we develop trigonomic functions, this is where they're going to be developed from, and understanding this. Okay, so one thing we want to be able to do here is pretty simple. We want to prove whether a point is on the unit circle, inside the unit circle, or outside, which is not a very complicated process, but it's about how you show it, okay? So a lot of this is just making sure you show a proper proof, basically, of how you know or don't know. All right, so how are we going to do this? Well, we're given a point. Here's a point. Now, notice how this point is not written in decimal form. Most points that we work with on the unit circle, we're going to write them as fractions so that we can avoid really ugly, nasty decimals, okay? So here's a point. There's the x coordinate, there's the y coordinate, right? Same with this one. I have one here written as a decimal also, right? All right, so we want to prove whether this is inside or outside the circle. So what do we want to do first? Well, step one is we want to substitute this point into x squared plus y squared equals the radius squared, right? Now notice how I'm not saying into x squared plus y squared equals 1. Okay, we want to sub it in, the x and the y, and we are going to solve for what the radius of this circle would be. So we want to see if we get a radius of 1. Okay, so if we get a radius of 1, then we know it's inside, it's on the circle, right? So basically, here's what we're looking for. If the radius is equal to 1, right, it's on the circle. Now, what if it has a radius greater than 1? So what if r is greater than 1? Well, then it must be on a circle that is larger than the unit circle, right? So we could think about a circle that would be bigger. Imagine we have, you know, a radius of 2 or something like that, like this, right? Well, we could have a, not very well drawn, but a much bigger circle, right? All right, so if it's greater than 1, then it's outside the circle. And of course, then that means that if it is less than 1, then it must be inside the circle. Okay, so those are our 3 scenarios. So when we do this, it's usually like, you know, if this had been in class, it's a really easy question, but the only place people usually use marks is they don't really use any kind of proper form. They just kind of write out a mess of a solution, and there isn't really a lot to go on there. So let's run through this. All right, so x squared plus y squared equals the radius squared. Or if you want to flip it around, radius squared equals x squared plus y squared. Let's substitute these 2 points in, right? See what we get here. Root 3 over 3 squared plus root 2 over root 3 squared equals our radius squared. So again, looking at these, right, these are coordinates just written as fractions, okay? And you'll notice, some of you might be thinking, you notice that root 3 on the bottom? That's poor form. We really shouldn't have root 3 on the bottom. It should just be a 3, but we won't worry about cleaning that up right now. But remember, actually, I'm just going to do a little side lesson here, because this might pop up at times. Remember when you get something like this, and we're not supposed to have a radical on the bottom. So you remember what we would do? We would actually multiply the top and bottom by root 3, right? So on top, you get root 2 times 3 is root 6, and root 3 times root 3 is the square root of 9. Well, what's the square root of 9? It's just 3. So this would be the proper way of writing that, okay? So really, this properly would be written like that, okay? But we're not going to worry about that right now because it's not like it's some final solution that we want to give. We're just working with these numbers. All right, so here we go. Let's square both of these, right? So root 3 squared is just 3, right? Because root 3 times root 3 is square root of 9, which is 3. And then 3 squared is 9. All right, root 2 squared is 2. And again, squaring root 3 is 9. Okay, so there we go. Oops, sorry, that's a root 3 on the bottom. My bad. Not a 3, so it should just be 3. My bad. All right, now we can reduce the 3 over 9, make it into 1 over 3 plus 2 over 3, right? So we can see where this is going. We're going to have 3 over 3, which is 1. So you know what? I'm just going to make that 1. Now, again, we're supposed to technically take the square root here, right? Which gives us plus or minus 1 equals the radius. And don't forget, we ignore the negative, right? Because we're talking about a length here. So when we're talking about a length, we don't want the negative. So we just ignore it, and the square root of 1 is 1. So our radius is 1. So that's the type of solution we're looking for, right? Solving for the radius, proving it. So since the radius is 1, this is on the unit circle. All right, so I've just written out an explanation, right? Since the distance from the origin for the given point is 1, well, I should have said 1 unit, right? And that's what our radius is. That's what we solve for, right? That's the distance, okay? This point is on the unit circle, okay? Now, which quadrant would this be in? Is it in quadrant 1, quadrant 2, quadrant 3, or quadrant 4, right? Well, both the coordinates are positive, so it's going to be in quadrant 1. So it would be somewhere here. Now, I'm not going to get super accurate to where it is. I'm just going to draw that it's somewhere in this quadrant. That's where it would be, right? Root 3 over 3, and I'm going to rewrite this like I said before instead of writing it like that because that just bugs me, right? It should be root 6 over 3. There we go, and the radius is 1. So there's a little sketch of it, where it's at, and there you go. So again, the radius is the distance from the center, from 0, 0. That's how we know it's 1. All right, let's look at the one next to it here. Same thing. Let's sub this in, except I'm going to do one that has decimals this time. All right, so pretty simple, right? We're going to substitute it in. Again, I am not setting the radius equal to 1. I'm trying to see what the distance is of this point. So we're going to leave the radius as what we're solving for. So we're going to have negative 0.25 squared plus negative 0.9 squared. All right, let's square both of those. And we end up with, I'm just looking, I got them written down here, 0.0625 plus 0.81. We're going to add them together and take the square root, right? And when you add them together, you get 0.8725, I believe. There we go. Again, we're going to ignore the negative, right? Because we're talking about a distance here, and we don't care about the negative. And when you square root it, you are going to get approximately 0.93 units. Now, that's less than 1, right? So that means this point is inside the unit circle somewhere. All right, so since the distance from the origin is less than 1 unit, this point is inside the unit circle. So this is a way that we can determine a distance, right? And that's what I'm trying to show you here, that we can figure out distances from the unit circle. Now, what quadrant would this be in? What is it in? 1, 2, 3, or 4, right? Just reminding you where your quadrants are. 1, 2, 3, and 4. Well, both the coordinates are negative, so it's down here somewhere. And again, it would be inside the circle somewhere. I'm not being super accurate, right? Because our radius is approximately 0.93, and again, this point would be somewhere inside the unit circle, okay? So that's the first skill. Pretty simple skill, but it's more about than just finding, the number. It's also about understanding and how to explain this kind of stuff. That's what we're trying to get at here. Okay, we're going to do one more quick skill for this unit, or this lesson. Okay, and of course, just referring back to the last question, if you get a radius length that's greater than 1, obviously it's outside the circle. We didn't do an example of that because it would just be redundant if I kept doing more and more. All right, the second skill I want to go through is locating a point on the unit circle. So what's going on here is we're going to determine the missing coordinate by using the equation and the sketch, okay? I don't want you to do a quick little sketch. So here we go. So what I'm telling you is I'm saying, okay, there's a point somewhere on the unit circle that has an x coordinate of 1/2, and it's in the 4th quadrant, okay? I want you to figure out what the y coordinate would be and give me both coordinates together and draw a quick little sketch of it. Okay, so in this case, we're telling you it's on the unit circle. So like, what can we assume? Think about our equation, right? There's x, there's y, and there's r, right? Well, we know that radius is 1 because I am telling you it is on the unit circle. It's located right on the unit circle. It's located in the 4th quadrant, okay? So we're going to assume everything here is located on the unit circle, and the x coordinate's 1/2. All we got to do is solve for y, so it's a pretty simple question. Both of these skills are pretty simple. We're trying to just ease into more complex understanding of this unit circle. We're just baby stepping our way into it, okay? Because it's really important, okay? Don't discount this because this is what happens. Some of you guys used it a little bit in grade 10 and didn't touch it very much, right? And a lot of people just think, oh, all it was to solve just triangles and who cares about the rest of it, right? No, it's much more important than that. So that's why I want to go back and really focus on this a bit. So when you roll into grade 12, you're hopefully ready to tackle some of that stuff. All right, so look what I did. I subbed in what I know. I know the x coordinate, I know the radius. Let's just solve for y, right? So 1/2 squared, well, that gives me 1/4, right? 1 squared is just 1. All right, so we're just gonna, you can do this as quick as you want. You don't have to show 100 steps like I'm doing here, but it's gonna be 1 minus 1/4, right? So we're gonna get a common denominator of 4/4 minus 1/4, right? So 4/4 minus 1/4 is 3/4, and then we're gonna square root it, right? And it could be a positive or a negative value. So square root of 3/4, well, I can square root, remember, we can break this up separately. And again, I might be doing this in way more steps than we need here. Like this, right? We've learned that we can break a radical up by division into 2 separate radicals in our previous unit. And I can make this into root 3 over square root of 4 is 2. So that's as simplified as it's going to get. Now, what quadrant is it in? Do we keep the plus? Do we keep the minus? Do we keep them both? That's the question, right? Which quadrant is in it? It's in the 4th quadrant, it says. So that's down here, right? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. I'm using Roman numerals for quadrants just because that's like the classical way of doing it. I know Roman numerals have really fallen out of fashion in recent years, but when I was in school, it was still very common. All right, so it's down here somewhere. Now, again, our sketch does not have to be accurate. I'm just going to draw it to there. We just want to make sure we get in the right quadrant. So in that quadrant, what's the x and what's the y, right? The x is positive, the y is negative. So our y coordinate here, we want to keep the negative. So we want to keep that and get rid of the positive. So that's our y coordinate, negative root 3/2. So I want to, it says just find the y coordinate, but I want to write them both down. So our coordinates are going to be 1/2 for the x and negative root 3/2 for the y. That's really what we're looking for. What is the set of coordinates that make up that point? So there we go. There's the first one. Pretty simple, right? All right, let's do one more here after I finish coloring this in. Oh man, look, I'm going outside the lines. My kindergarten teacher would be so mad at me. All right, one more. The y coordinate is 3/7, and it says the point is located in quadrant 2. All right, so like we can draw a quick sketch of that right now if we want. It's going to be over here somewhere, right? There's quadrant 2. 1, 2, 3, and 4. So it's going to be over here somewhere. So when we get to the end, right, our x coordinate is positive, our y coordinate is positive, right? When we're in quadrant 2. All right, so we want to make sure we keep it positive. Oh, wait, the x coordinate is positive. What am I saying? Oh, my goodness, I must be out of my mind. The x coordinate is negative. All right, there we go. So let's substitute this in. X squared plus y squared equals the radius squared. All right, so what do we know again, right? Let's keep a little catalog. We know the radius is 1. We know the y coordinate is 3/7. It's the x coordinate we're solving for, right? All right, so x squared plus 3/7 squared equals 1 squared. All right, so pretty simple stuff. We got 9/49 equals 1. We're going to subtract that from the other side. So we're going to make the 1 into 49/49 minus 9/49. So we have x squared equals 40/49. We're going to take the square root of both sides, right? And plus minus. I'm just going to jump to square root in the top and bottom separately. Now the bottom's easy because the square root of 49 is going to be 7. What about the 40 there? Let me just take this square root of 40 aside for a second. Let me just bring it up here and think about it. So remember, we can break that down, right? Because what can we break 40 down to? Well, 40 divided by 2 is 20, so 2 times 20, right? Well, what can I break 20 down to? 20 divided by 2 is 10. Now you can break 10 into 2 times 5, but that's not going to give me another pair, right? So remember how we would simplify a radical? So I have 2 times 2, which is 4. Square root of 4 is 2. So in other words, the square root of 40 can be written as 2 root 10. Now again, if some of you are like, well, why didn't you break the 10 down? Because 10 only breaks down to 2 and 5. There isn't going to be another pair, right? So that's as simple as that's going to get. So when we write this, it should be 2 root 10. That would be the simplified radical. And we are going to keep the negative because we said over here, right, even though I said it wrong at the start, x coordinate is negative. All right, so there we go. There's our x coordinate. So what's our final point? It's going to be negative 2 root 10 over 7, comma 3 over 7. Those are the coordinates. All right, to make up that point. Okay, so that's the end of this lesson. Make sure you try the homework. It's pretty short, but really follow along with what I did here.